Hello everyone, my name's Abhishek and welcome back to my channel. In today's video, I'll walk you through an AI platform that every platform engineer and every DevOps engineer should definitely pay attention to. Now, I'm not talking about Claude, Codex, or Copilot. They are all developer centric. They can help developers write code faster and better. But what about platform engineers? You see, traditionally, platform engineers make use of open source platforms like Coder and set up self-hosted environments or cloud developer environments so that developers makes use of this environment and they work within a self-hosted, controlled, and governed environment. Now, in today's world, AI agents are the primary actors. So, how does platform engineers ensure AI agents also work within a self-hosted environment, controlled environment, governed environment? As simple as developer who is using this AI agent only makes use of approved set of MCPs or approved set of skills. This is exactly where Coder has recently launched Coder agents. In today's video, we will deep dive into Coder as well as Coder agents. And this is going to be a full-fledged video. I'll not only explain you how Coder agent is going to solve this problem, but I'll also show you how to set up Coder on a Kubernetes cluster so that you can also do it within your organization. I'll also show you how to make use of Coder agent using the workspaces concept. And towards the end of this video, I also have a cool demonstration for you. So using the Coder agents, we will create a pull request and I'll show you how this end-to-end process is very secure. So this is going to be a very interesting video. Make sure you watch it till the end. And all the useful links for this video are in the description as well as in the pinned comment. Let's get started. Let's start with understanding the problem statement better. Imagine a large organization. Let's say within the organization, there are multiple teams, and within the teams, there are multiple developers. Now, it is quite common. Different developers like different AI tools. Some might like Cursor, some might like Claude, some might like Codex. Given a chance, developers would like to install AI tools of their choice. And within the AI tools, they like to install MCPs of their choice, skills of their choice, or any packages of their choice. Now, if you look at developers' point of view, this is all cool because these agents are capable. They can help developers achieve their task. But when you look at platform engineers' point of view, there are few things that are concerning. What platform engineers are concerned about? They are concerned about security. Platform engineers are concerned about governance. Platform engineers are concerned about access control, auditability, and most importantly, platform engineers are concerned about cost management. But Abhishek, what is the problem with this workflow? Why platform engineers care about these factors? Very simple. Just imagine developers can install any AI tools, they can configure any MCP server, any skills file. What if one of the MCP server or skills that they copied from the internet is vulnerable? Through this vulnerable server, hacker can get access to the developer system, and from there, hacker can get access to complete organizational network. This is exactly what happened in multiple recent attacks. Now, to avoid this, platform engineers care about security, governance, access control, auditability, and cost management is the added advantage. And how platform engineers ensure this? That's the most challenging part. And that is exactly where platform engineers can make use of Coder agents. Let me first walk you through the platform engineer workflow using Coder agents, and then I'll show you the same thing through the demonstration. Very simple. First of all, platform engineers would install the Coder platform, let's say on a Kubernetes cluster or on a virtual machine. Once the platform is installed, once it is accessible, platform engineers would create something called workspaces on the platform. Now, workspaces are nothing but the self-hosted environments. It can be a Docker container, Kubernetes pod, or even a virtual machine on AWS. And these self-hosted environments are the ones that agents would use for their execution. These workspaces are controlled. Platform engineers can define the resources like the CPU, memory. They can also define the packages that this workspaces would have. Like they can install the set of packages. Once this is done, then the platform engineers would also configure the model provider and set of models, like the OpenAI provider and OpenAI models that agents can use. And finally, platform engineers can also configure the agent in a way they can define the set of MCPs that agent can use, the set of skills that agents can use, so that the MCPs and skill are also controlled and governed. This is what platform engineers would get started with. And then developers can log into the platform through the SSO, through access that they have. And once they log into the platform, they can head to the agent, they can select the model, and most importantly, they can select the workspace that they have access to. Not every developer would have access to every workspace. And then they can simply provide the prompt and work on the task using the agent. So agent would finish the task by accessing the workspace. It would finish the execution on the workspace and probably create a pull request. That's all. Now let's look at the same thing through the demonstration so that you understand this concept better. So as the first step for the demo, let's install Coder on a Kubernetes cluster. Don't worry, every single step is part of their official documentation. We will follow the same steps. Just to let you know, I already have a Kubernetes cluster. That's the only prerequisite. Now, once you have a cluster, just install the Coder namespace. This is your step one. Then step two, install a Postgres instance. If you're using Coder in production, I would recommend you to go with manage Postgres instance. But if you're doing a proof of concept or just getting started with Coder, you can even use an in-cluster Postgres instance. That is exactly what we're going to do. Now, once this is done, you need to store your Postgres credentials so that Coder platform can later use this Postgres instance. You can create a Kubernetes general secret for it. kubectl create secret. Now just wait for a few seconds and see if the Postgres instance is running within the Coder namespace. Once this is in the running state, we can start with installing the Coder. For that, there is an official Helm repository. So let's first add the Helm repository for Coder. There is a sample values.yaml file, which I have already configured. This is the one. So finally, just run the Helm install command. This might take few seconds to start the Coder instance. You can verify by just running kubectl pods -n coder and make sure you watch the pods. And in less than a minute, we have the Coder platform running. We can access the platform using the Coder service, kubectl get service. Now, because I'm using a local Kubernetes cluster, I don't have a load balancer IP. In your case, if you're using a public cluster, you can get it, or you can just use kubectl port forward. I'll use the port forward and I'll expose the Coder application on 4000 port. Perfect. Now let's head to the browser. There you go. So we have the Coder platform running. Let's create an admin account. When you get started, you can also avail the 30-day trial for premium. Now we have the account. We are logged in as admin, let's say as a platform engineer. We will start with creating workspaces first. I'll click on create new workspace. There are some templates available. I'll click on create new one. I can choose the template. I'll use a Kubernetes pod as the workspace. So basically agent will perform its execution within a Kubernetes pod. Use this template. Just provide the basic details and create the workspace. The interesting part is that Coder makes use of Terraform to create this workspace or the environment for you. You can also see the Terraform scripts in detail. If you want, you can make changes to it as well. But I'm not going to make any changes. I'll just create the workspace. While creating, you can provide the name for the workspace. I'll call this as Kubernetes. You can configure the resources like CPU, memory, or just go with the default. Workspace is being created. This would probably take less than a minute or two. Perfect. Workspace is created. Now, if you want, you can connect to the workspace. Just click on the terminal. You get access to the workspace. You can install the packages. Let's say you want to configure Git so that agent can later create pull request. You can do that. Or maybe you want to install a specific package. You can also do that. We'll get back to it. For now, we are fine with this. Now, if you go back to workspaces, you can also define which user will have access to this workspace. This is how platform engineers can perform access control. So you have an option for sharing. You can see here, you can select the user who will have access to this workspace. Cool. Now let's head to the agent section. In the agent section, you will start with creating, the platform engineers would start with setting up the provider configuration. Click on add provider. You have options. Let's select OpenAI provider. You can head to the OpenAI platform and you can create your own key. Or if your organization already has one, you can just provide the API key and click on add provider. Now the provider is added. One final step, you just have to define the models. So as you can see, platform engineers have the complete control of the platform. What AI providers to use, which models to provide. So just click on add models within the OpenAI provider. You can select the models. For example, we will go with the GPT 5.5. You can create multiple models as well. For example, I will add this model, then I can click on add and I can add one more OpenAI model. Or you can create combination of OpenAI and Anthropic models as well. Now the basic agent is created. So platform engineers can head to the agent and also configure the MCP servers or the skills configuration. Cool. So this is the basic platform engineers configuration. Now from developers point of view, let's say there is a development team which is working on this Hello World MLOps project. This is a very good project, but the README file does not provide enough information. So they want to make use of the coder agent and update the README file. Now developers can just log into the coder platform and they can make use of coder agents. So this is a coder agent for them. They can just select the workspace. So once the developer logs in, they will have the set of workspaces that they have access to. They can select the workspace and provide with the prompt. For example, improve the README file for my Hello World MLOps project. But Abhishek, where is this Hello World MLOps project? This is what developers or platform engineers can configure within the workspace. As I told you, they can head to the workspace. They can connect to the workspace through the terminal. And here they can configure the GitHub repository. Let's say git clone, and this is my Hello World MLOps GitHub repository. Now that the project is available within the workspace, let's see if the agent can implement the action. We'll go back to the agent, improve the README file for my Hello World MLOps project. So you can see it figured out there is the project. It figured out the location. It started reading the files. It's going through every file in detail. It's also going through the existing README file, which does not have many details. There you go. It says only readme.md file is modified. Now here, either developer can ask to create the pull request or developer can go back to the terminal and see the changes that were made. Like go back to the workspace. Instead of terminal, they can also use the Visual Studio Code so that the diff looks better. Hello World MLOps, readme.md. You can see here, this time the readme file is much detailed. Like this is a previous readme file. If we go back, so this is my repository. Here in the readme file, there are very basic details, just a quick start and some simple information about the repo. Whereas now, what Coder Agent has done, what is the project about, the project structure, prerequisite, and different actions that this project is implementing. And all of this within the self-hosted workspace. If the changes looks good, developer can just go back and say, create a pull request. It's working on creating the pull request. Perfect. So this is the URL for the pull request. Let's open it and see. The pull request is ready to merge and these are the clear changes. Now one of your peers can review this pull request. If they're fine, they can accept the PR or they can suggest you some changes. You can go back and work with those changes even using the same coder agent. So the interesting takeaway here is that AI agents are becoming the primary actors. They need environments, they need permissions, they need governance. And as a platform engineer, this is the best time to excel. You can create workspaces and you can make use of coder agents so that your agent works within a secure environment. So I would highly encourage you to try out coder agents within your organization and drive your organization towards a secure and compliant development workflows. As you saw, it's super easy to get started. I'll share all the useful links in the description. Finally, I would like to thank Coder for collaborating on this video. If you have any questions, do let me know in the comment section. I hope you found this video insightful. See you all in the next video. Take care.